Ever looked at a bicycle chain and wondered how it perfectly grips those gears without slipping? Well, the secret lies in two simple geometric lines, tangents and secants. In this explainer, we're going to break down this entire chapter for you so you can absolutely ace your exams and, even better, start seeing math everywhere.
I mean, just look at that. Before we even get into the textbook definitions, see how the straight parts of the chain just graze the edges of those circular gears? That, right there, is a tangent in action. It's pure, beautiful geometry in motion. And I promise, by the end of this, you're going to see these shapes all over the place.
So here's our game plan. We'll start with the absolute basics, then we'll dive into the two big theorems that unlock everything. After that, we'll apply them to actual exam questions, and we'll finish up with a super fast summary and a quick quiz to make sure you've got it down. Let's jump in. Okay, first things first, let's get our foundation solid. It all comes down to the difference between a tangent and a secant. Once you see this clearly, I promise, the rest of the chapter just kind of clicks into place. Let's talk about the secant first. You know, the name itself is a pretty big clue. Think of it as making a section or a slice. A secant is any line that just cuts right through a circle, hitting it at two different points. It goes in one side and right out the other. Simple as that. And now for the main event. The tangent. Now, a tangent is totally different. It doesn't cut through the circle at all. It just gently touches it. It grazes the circle at one, and only one, single point. And we've got a special name for that spot, the point of contact. It's like a line that gives the circle a quick high five and just keeps on going. So let's put them side by side. The tangent just touches the outside at one single point. The secant cuts right through the interior, hitting 2 points. And that's really the big difference you have to remember. One touches, the other cuts. Got it? Good. All right, now we get to the really powerful stuff, the two key theorems. I want you to think of these as the ultimate rules of the game. Once you know these two rules, you can solve pretty much any problem this chapter can throw at you. They're basically your secret weapons for the exam.
Theorem number 1 is so simple, but it is incredibly powerful. It just says that a tangent is always perpendicular to the radius at the point where they touch. So, to put it even more simply, wherever a radius meets a tangent, boom, you get a perfect 90-degree angle. Every single time. No exceptions.
And hey, if you need a way to remember that, just picture the letter T. The horizontal bar at the top, that's your tangent. The vertical line, that's your radius. And what do they make? A perfect right angle. T for tangent, and it looks just like the 90-degree angle it creates. Now for theorem number 2. This one is also a game changer. If you pick any point outside a circle and you draw two tangent lines from that point to the circle, the lengths of those two tangents will always be equal. And this is the part that's so cool for solving problems. It immediately gives you an equation. This length equals that length. It turns tricky geometry into simple algebra. All right, we've got the theory down. Now it's time to put it to work. Let's get our hands dirty and solve a couple of classic exam-style questions together, step by step, so you can see exactly how these theorems play out in real life. Okay, check out our first problem. We've got a circle. Its radius is 5 centimeters. There's a tangent line, PQ, that touches the circle at point P. The distance from the center, O, to the point Q on the tangent is 13 centimeters. Our job is to find the length of the tangent, PQ. So what do you think? Which theorem is screaming out to be used here? Let's walk through it. First up, we know the radius, OP, has to be perpendicular to the tangent, PQ. Why? Because of Theorem 1. That means triangle OPQ is a right-angled triangle. And whenever you see a right-angled triangle, what should pop into your head? Yep, Pythagoras' theorem. We just plug in the numbers we know. 13 squared equals 5 squared plus PQ squared. We do a little bit of quick math, and we find that PQ is exactly 12 centimeters. See how Theorem 1 was the key that unlocked the whole thing? Okay, let's try a different kind of problem. This is a classic proof question, and it's all about Theorem 2. So we have a quadrilateral, ABCD, and it's drawn around a circle so that every side is tangent to it. We need to prove that the sum of opposite sides are equal. Now this looks kind of tricky, right? But it's actually just a super clever use of our second theorem. The secret here is to see that each corner of the quadrilateral, A, B, C, and D, is an external point. And from each of those points, we have two tangents to the circle, so what does Theorem 2 tell us? It tells us that AP equals AS, BP equals BQ, CR equals CQ, and DR equals DS. We just write down those 4 simple equations. Then we add them all up. And like magic, the terms rearrange themselves perfectly to prove that AB plus CD equals AD plus BC. It's an amazing example of how one simple rule can solve what looks like a really complex proof. Wow, we have covered a lot, so let's pause and pull it all together. This next slide is your ultimate revision tool. Seriously, if you've only got a minute before your exam, this is the one slide you need to look at. And here it is, the whole chapter on one slide. A secant cuts through at 2 points, a tangent just touches at 1 point, Theorem 1 says the radius and tangent meet at 90 degrees, and Theorem 2 says the two tangents from an outside point are equal. I would highly recommend you pause right here and take a screenshot. This is your cheat sheet for the entire chapter. Okay, now it's your turn. Enough of me talking. I'm going to put up a list of 10 revision questions. I really want you to pause the explainer, grab a pen and paper, and actually try to solve them yourself. Trust me, it's the absolute best way to make sure these concepts are locked in. All right, here are your 10 questions. Go ahead and hit pause now and give them your best shot. Okay, you ready? Let's see how you did. Number 1, a circle can have an infinite number of tangents. Number 2, using Pythagoras, you get the square root of 119 centimeters. For number 3, the distance is just the diameter, so it's 14 centimeters. Number 4, from an external point, you can draw exactly 2 tangents. Number 5, back to Pythagoras, the radius is 3 centimeters. For 6, the answer is 50 degrees. Number 7, that's a secant. Number 8, a circle can have 2 parallel tangents at the very most. Number 9, that's the point of contact. And for number 10, the logic is that the tangents are both perpendicular to the diameter, making them parallel. So, how'd you do? So there you have it. You've officially cracked the code of tangents and secants. You've got the definitions, you've mastered the theorems, and you've practiced the problems. So my final challenge to you is this. As you go about the rest of your day, where else will you spot these rules in action? Look for them in pulley systems, in the way a ball rests on the ground, or even the way the setting sun seems to just touch the horizon. The geometry is all around you, just waiting to be discovered. Thanks for joining me.